Okay, I'm going to restart this section all about formatting and storage just because, I really got way too into it and started to describe a lot of stuff that I probably um, bored people with. And it's not that it's not there, it's all there as part of the reading material, but it's again really not my goal to go through and just read the chapter for you, even though some people might like that. So I'm going to start over again and make this much shorter than what it was. Cover the highlights to give you a solid base to get going. All right, so when we start looking at a logical structure of a disk, meaning that we're not looking at physical platters, we're not looking at how the arms are moving, we're looking at the logical structure that Windows uses or Linux uses, whatever OS uses, we start to have to define some terms here. One of them is clusters, and I kind of explained that in Windows NT, New Technology File Systems, NTFS, 4096 bytes is kind of the way that they're doing it now. And we looked at the fact that the cluster size could be that if it's one of these newer drives. And so you see here that clusters are sets of tracks. Well, see, it depends. If I'm going to take and format, and we're skipping a space in here, and we're going to talk about in a minute, but if I'm going to format this NTFS and I just accept the defaults, that's 4096 bytes. That may not match the clusters that are, I shouldn't say clusters, that may not match the tracks. And so we would say, well, this cluster is actually spreading across a number of tracks. That's how I should say that, right? We got 4,000 bytes, but if the track size is only 512, then we've got to combine those together to make 4,000. And that's what they're describing here, is that your clusters are something that the operating system uses, not the hard disk itself. The hard disk uses tracks, sectors, and that kind of thing. The cluster is what Windows is dealing with. And so then that way you're not bound, right? You're not bound to that same physical structure. You can use something else. So within Windows, for instance, you can have a cluster size of, well, I don't know what it goes, so 32K, I think. We could look it up if I had something to format. And again, it usually chooses 4,000 and the low end at 512. So if you had 512 tracks, that's how the size they were, 512 bytes, then you could format the cluster size the same. Would you want to do that? No, that's not going to do anything for you. Being able to change the cluster size is really dependent on what you're storing. And so the only time you really would change cluster size is if you were a server admin, really, and you're looking at this, say, 10 terabytes that you're going to format in some way. And then you would look at, well, what kind of data is going in here? So, if this sounds familiar, it's because I described it in other classes. If you've got 10 gig files, right, that's what you've got, then you would make your cluster size bigger because the OS then doesn't have to do as much addressing. And you don't have to have as many locations of all these little clusters. You can have bigger clusters, so a smaller address of where is that. But if it was a documents, right, we're going to store millions of documents on this. Though those tiny. I mean, you're talking about probably an average of 200 kilobytes. A large document might be 4 megabytes, not gigabytes. Then you would make the cluster size smaller. And we'll look at that in just a minute as to why. So that kind of goes on, talks about all the different kinds of things you can do, and the fact that, in fact, it would sometimes cross-link files and lose clusters, and you can actually run an F-disk on it. And this describes the process of what it goes through to do that. But you can run check disk on your system, even if you don't have FAT, you can run it on NTFS and see if it's okay, and see if the clusters are okay. Now, it's very rare these days for clusters to be, writing over each other. And that's really one of the things that can happen. You have these clusters and the computer thinks this cluster starts and ends here, and it thinks this cluster starts and ends here. And that's bad because there's this overlap in the middle. See the overlap? So we don't want that. We run a check disk, and this is what happens. If you run a check disk /F, it'll actually tell you, I'll do this the next time you restart, because the F means fix the problems that you have. I would say run it first and see what happens, just so you can see it. Run a check disk. As a matter of fact, CMD. I'll just pull up the command prompt. You can see I haven't even used this one because McBride hasn't even changed the colors. CHK-DSK. Now you can actually do this if you right click on the volume, drive C, drive D, whatever, and then go to properties, and you'll go under tools. Access denied. You don't even have the privileges to do that. You'd have to run it in elevated mode. Why is it doing that to me? McBride, aren't you an admin? Oh, well, I don't make myself the admin. So I'd have to run an admin. Can I do sudo? Sudo. Yeah. Anyway, so wasted a little time there. I was just going to show you the same screen that they have there. Now let's talk about slack space. This is actually a little more important. Slack space. It's cool. I should create a website called Slack Space. There probably is one. Anyway, when we go and look at the properties of file, this is just a little screenshot that I had to take. I'm going to look at the properties. I will see on the disk that the size of this file is actually 21,909 bytes. That's pretty small. And then the size on the disk is actually 24,576. Yeah, so we talk about this in other classes. So again, if you remember, awesome. If not, here's a refresher. This is the actual size of the file. That's how big the file is. But because of the cluster sizes, I end up with a portion of a cluster that's not being used. And that's called the slack. So there's a piece of this storage space that doesn't have anything on it and won't ever have anything on it. That's why if I was storing a bunch of these small files, if I make smaller clusters, I end up with less wasted space. And so, normally, again, NTFS is saying 4,000 bytes, and that'll take up quite a few. But you would find out, right? If we take 4,000 and we divide it into 21, what do we get? If we divide it into 24, what do we get? And you get that space, that little tiny slack. Now, it is important for another reason to know about that slack, because hackers can actually use their program to say, let's go through and find all these spaces that aren't being used, and let's jam our information in it. So with that special program, then you could read that information where maybe you have a Word document, right? And it's taken up a certain amount, and then you got this slack right here. That Word document's only going to read what it needs to read. It's not going to add on the other, because it's got information telling it, I start here and end here. So when you use that slack to do your hiding, then it's just sitting in there. And the only way it's there is if you put it there, right? So that slack space can be used to hide stuff. So they kind of show you, hey, this is kind of what I just showed you broken down. And you can have RAM slack and you can have drive slack. You can have spaces where hackers will say, well, this part of RAM is not being used, so I'm going to hide that in there. Now, the two different kinds, this is something that I almost wish they'd talk about prior to this, but I get why they don't. There's two different ways these days to actually, gosh, how would I put it without saying format? Set aside or decide how a partition is going to work on a hard disk, right? So again, we pull up disk management. And right here in disk management, we see I got a basic disk 0, a disk 0 that's basic. You can change that, change it to dynamic. That's a lesson for another time. But here's my C drive. And I cannot see these unless I come into this program and look at them. These are hidden partitions. I see this partition and I see this partition when I go to my files. As a matter of fact, they're both on one drive. So let me just jump down to this PC. Right, I don't see 4 partitions here. I see C and D. The ones that are labeled C and D. Those are the ones I see. These are hidden. So before you can actually create these partitions or these drives or volumes, you have to have a way for this physical disk to know how it's going to be laid out. You're starting to talk about the link between your operating system and accessing data and your boot up process and being able to turn that over to the OS. Two ways of doing it: master boot record. Now, master boot record, that really refers to that first sector, sector 0. So the MBR, the master boot record, contains this is how I'm going to boot. But also MBR is a type of partitioning way. So that's a way of partitioning. Yeah, so it gets a little confusing there, right? And so they get into the details of how that is formulated, and you get to see it in hex and octal and where it's located and all that, which is great. And that's stuff that, you know, as you really would get into this, you're going to use. I haven't checked out this latest lab. Should have done that prior probably, but you may have to know this in a lab. And yeah, you probably want to pull this up if you need that information. If you were doing this stuff all the time, right, you'd have that memorized. And so you can actually back up that master boot record that really has all the stuff. And on a master boot record, because we're going back in time for that, you have a primary partition, which is must be bootable. It has to be primary. You have to be able to use it. And then the rest of the space is extended off of that. So it's kind of old school. This breaks down, you just read that has to do with your sector 1, the volume boot record information, physical layout of the disk. That's why some people will say, well, you really want to get rid of information? Yeah, you should delete the partition table. And it's like, that's a harder thing to do. It's a more techie thing to do, but it doesn't get rid of anything. You're just getting rid of a little sector that stores where the partitions are, and they're all still there. All the data is still there. And then, of course, how it breaks that down, where all that information is actually set. And then we have the other. So we have master boot record, which deals with two things. Where is the master boot record? And a way of not formatting, a way to allow formatting on a hard disk. So MBR allows primary and extended. That's what it allows. It goes way back. So now we talk about this globally unique identifier, this Guid. So basically what happens is, how do we really start getting security to the lower level? How do we start tracking what people are really, really accessing and doing? And GUIDs are used for that. They're a 128-bit unique number that Windows generates for identifying a device, a document, a database, a user. As an example, let's say a hacker gets on your network, and so instead of sitting in the office and trying to do their hacking, they're able to access a manager's office, and they duplicate that computer. So they do a bit copy on that computer. Now they take that information and they go set up another machine, and now they're sitting in a closet someplace accessing information like they're the manager. Well, Windows actually has a GUID for that particular user, for that particular Windows. And so you can actually flag that and go, hey, I've got the same computer accessing information from two different locations. Something is up, right? So that's kind of what we're talking about here. But it goes way below that, right? It does database tables. In the registry, it's identifying what programs, right? DLLs and comms are part of programming. So let's track that. Let's make sure that we're not getting some other portion of a program jumping in that shouldn't be there, right? So all these unique identifiers are important. So saying that, we have something known as a GUID partition table, or a GPT. That is the way we do things now. So not joking, Windows kind of obscures this a bit. So it's not really best to use Windows Media, disk manager to figure this out. Use something else like, well, just use something in Linux and you'll see it. Parted Magic, Gparted, that kind of stuff. basically, when you have a drive, that's why I actually force people to look at it in Linux, even though, they're just barely getting a little information about it. When you have a drive in there, you can't do anything with that drive until you tell it, is this master boot record or is it GPT? In other words, there's a layer below your formatting that has to be in place, and that's because we're tying the UEFI and BIOS to booting this whole process. So we need that down there. And if you would only select MBR if for some reason you needed way backward compatibility. Otherwise, you should use GPT. And that's why you'll see it listed. GPT is a Guid partition table. And now you know what a Guid is. Now you know it's this 128-bit ID that gets stuck on all this different stuff to make sure it's secure. So Guid is a part of UEFI. You cannot have unified extendable firmware interface and boot into, and it's really hard, seriously, boot into the later versions of Windows 10 without a Guid partition. So it's got to be GPT. You can actually install it. I've done it, and it takes a lot because it's like, hey, we need to be securing all this stuff, right? So that's in there. And they also mention, hey, the MBR partition scheme uses, they start talking about that again because you realize that there is still a master boot record where the other one got its name from. And they give you little details on GPT. The main thing that I'm trying to express to you is that traditionally, when you say MBR, you're actually saying, I need to make sure this is compatible with 1990. When you're saying GPT, you're saying, I need this more secure. That's kind of the bottom line of what we're dealing with. So, and of course, the other thing is what they're showing you here. You end up with, I have this physical disk. It doesn't matter if it's a hard disk drive or a solid state device. What I need to be able to do is get from, I'm booting the computer into the OS. And in order to do that, we have a master boot record. This is where I'm going to be booting from, and it's protected, so it's not easily deleted. Then you have, okay, now I'm a GPT partition table. So this is how I've got to be set up, this information. Now I can go ahead and partition the information and then format these things however I want, in TFS or whatever. So it's not just about the formatting, it's about what's below it. And that, again, that's stuff that is important to you in this class, because if you are going to do forensics investigation, you will be dealing with data that's in here and data that's in here and what this is saying, right? Especially if somebody perpetrated an attack to crash things. Anyway, that is, there's your hex. Told you hex was coming. I'm gonna have to go do the lab. I mean, it really sounds so fun. If they're using any of this stuff, right, it's gonna be so much fun. I'm sure they probably have a portion of lab where you're just creating some partitions. Lots of stuff in here. But I'll stop it there because the boot process is a whole nother matter.